In the beginning, the universe underwent a rapid inflation that lasted only 10 to the minus 32 seconds. After inflation, the size of the universe increased to a factor of about 10 to 30. That's 1 followed by 30 zeros, an enormous number. Minute random quantum fluctuations in the structure of the universe that were present at the moment when inflation started were amplified up to cosmologically large scales during inflation. The first space-based measurements of the CMB were carried out with NASA's Cosmic Background Explorer (COBE) satellite in 1992. It confirmed for the first time that temperature of the CMB was not identical all over the sky. The Wilkinson Microwave Anisotropy Probe, WMAP, is the NASA Explorer mission that launched in June 2001 to make fundamental measurements of cosmology. The science team produced the first fine-line resolution of 0.2 of a degree full map of the microwave sky. At this level of resolution, the science team incorrectly determined that the distribution of these fluctuations follows a bell curve with the same properties across the sky, and that there were equal numbers of hot and cold spots on the map. Planck is a space observatory operated by the European Space Agency and designed to observe anisotropies of the cosmic microwave background radiation. Anisotropy is the property of being directionally dependent. It can be defined as a difference when measured along different axes in a material's physical or mechanical property. An example is light coming through a polarizer. Another is wood, which is easier to split along its grain than against it. In reviewing the data provided by Planck, we find anomalies. One is an asymmetry in the average temperatures on opposite hemispheres in the sky, indicated by the curved line, with slightly higher average temperatures in the southern ecliptic hemisphere and slightly lower average temperatures in the northern ecliptic hemisphere. This runs counter to the prediction made by the standard model that the universe should be broadly similar in any direction we look. There is also a cold spot that extends over a patch of the sky that is much larger than expected, circled. In this image, the anomalous regions have been enhanced with red and blue shading to make them more clearly visible. A controversial claim by Laura Mersini-Houghton is that it could be the imprint of another universe beyond our own, caused by quantum entanglement between universes before they were separated by the cosmic inflation. She said that standard cosmology cannot explain such a giant cosmic hole, and made the remarkable hypothesis that the cold spot is the unmistakable imprint of another universe beyond the edge of our own. If true, this provides the first empirical evidence for a parallel universe. The detectors on board Planck are highly sensitive. They will look for variations in the temperature of the CMB of about 1,000,000 times smaller than 1 degree. This is comparable to measuring from Earth the heat produced by a rabbit sitting on the moon. The Planck telescope was built at a cost of $1 trillion. The information gained by the higher resolution has become important in determining if there are more than one universe in our existence. The implications of a multiverse will have effects upon philosophy, theology, and the basic core and foundation of physics.